By the end of the lesson, I will be able to use models and rules to subtract integers. In your notes, write the word phrase for the following integer expression. You should write 4 plus 7. Let's think of it this way though. How about 4 and positive 7? So positive 4 and a positive 7. In your notes, write the word phrase for the following integer. Last year, you would have wrote 4 minus 7. But this year, you're going to write positive 4 and negative 7. You do not have to write this, however, we are going to start thinking about each integer individually. While reading each integer expression, we will say the word and instead of plus. This allows the sign in front of the integer to become that integer's sign. So in your notes, we're going to read and write the following expressions. Make sure you have the expressions written so that you know what the words belong to. So 10 plus 10, we're actually going to write that as positive 10 and positive 10. Notice that I didn't write the word positive because when I just write 10, I know that it's positive. So 3 minus 6. Instead of saying 3 minus 6, we want to say positive 3 and negative 6. The next one, negative 7 minus 4, we're going to now read it negative 7 and negative 4. 9 plus negative 3, we're going to read it as 9 and negative 3. 8 minus 4 plus 5 minus 1, we're going to read and write it as 8 and negative 4 and 5 and negative 1. The next one we're going to write as negative 4 and 9 and negative 1 and 9. And lastly, we're going to write 7 and negative 2 and 6 and negative 10. Remember from the adding integers, there are two teams when fighting on integer hill. We have positives and we have negatives. Essential questions from yesterday, except we have one addition. So the question is integer hill positive? If not, who are the spies? That's the extra part from yesterday. Question 2 is who's going to win, and question 3 is by how many. What happens when integer hill is not positive? So if integer hill is not positive, when I see subtraction, that's when integer hill is not positive. There are spies. Who are the spies? The team to the right is always the spy. Notice that this is a subtraction problem, so integer hill is not positive. Integer hill must be positive, though, when I'm adding integers or subtracting integers. So my subtraction sign is integer hill. I need to change integer hill to positive, and the guy to the right is the spy. He seems to look positive right now, but he's actually a negative. So when we set up our hill, we're going to have positive 4 on the left and negative 7 on the right. So we've changed integer hill to positive. Now we need to think about who's going to win. I think negatives are going to win because they have more people on their team. So I know that my answer is going to be some number, some integer that is negative. And by how many? When we cancel out by zero product property, I have 1 over here that cancels out 1 over here. 1 on the left that cancels out 1 on the right. 1 on the left that cancels out 1 on the right. 1 on the left that cancels out 1 on the right. So we're going to have the negatives win, and there are 3 remaining that are alive. So 4 plus negative 7 is negative 3. Okay, I see subtraction, so I know that integer hill is not positive. However, I'm going to change it to positive. So I'm going to change my subtraction to addition. That means that the guy to the right is the spy. He's actually a -7. So on the left of my hill, I have -4, and on the right of my hill, I have -7. Here is my picture. So I have negatives on both sides. We know that negatives are going to win because negatives are on the same team. So when they get to the top of the hill, they're going to figure out that they're not going to fight one another. They're going to join. So I'm going to have negatives winning, and there are 11 of them because when they combine, 7 and 4 is 11. All right, I see subtraction again. So I need integer hill to be positive. The guy to the right is the spy. He looks like he's negative, but when he shows his true colors, he's actually a positive. So I actually have a 9 plus 6. We're not going to draw a picture for that. 9 plus 6 is 15. They joined forces because both of them were positives. This one's going to be without a diagram. I have -1 minus a -5. So I need to change integer hill to become positive, which tells me that the guy to the right is a spy. So I have -1, integer hill is positive, and the guy to the right actually becomes positive. So I have a -1 fighting or versus a +5. Positives are going to win because they have more people on their team. And they're going to win by 4. Because if one of the negatives kills or cancels out one of the positives, then there are only going to be +4 remaining. Again, no diagram. However, I see subtraction, so I know that I need to change it to addition because integer hill has to be positive. When I change integer hill, then the guy to the right has to change because he's a spy. So that 8 is actually a -8. When I have a negative fighting a negative, then they're going to join forces. So who's going to win? I'm going to have negatives winning. They're going to join forces because they're both on the same team. And 11 and 8, when I join them together, I get 19. So negatives are going to win by 19. Is integer hill positive? It's not. So I have to change it to positive. Change the guy to the right because he's a spy. So I have 12 plus 12. They're both positive, so we're going to join forces, and when they join, we're going to get +24. Is integer hill positive? It is not. I'm going to change it, which tells me I have a spy. The guy to the right is a spy, so I changed his sign also. So I have 10 fighting a +2, +10 fighting a +2. They're both positives, so my answer is going to be positive, and they're going to join forces because they're on the same team to get +12. I could write just +12 like this. Either way is okay with me. Is integer hill positive? It is not. I'm going to change integer hill to be positive. That means the guy to the right is a spy. I need to change his symbol also. So I have a negative fighting a positive, and they have equal amount of people on their team. So if 10 people fight 10 people, and based on our zero product property, right, these are all positives, then all of our guys are going to cancel out because one positive with one negative cancels. So our answer is going to be 0. We're going to have 0 people still alive after a zero product property cancels them out.